Hi, physical science. We're back at it again. It's Thursday, the 7th of May. I'm on page 568. 568, you've got your periodic table, right? We're going to talk about naming now. Yesterday, what we talked about was writing a formula from a name. Let's practice one. Aluminum, phosphide. That's phosphorus. That's aluminum. Al is aluminum. Phosphorus is P. Aluminum is +3. Phosphorus is -3. Crisscross that thing, and you're going to get Al3P3. But it looks like you can reduce that, so you're going to go to AlP, and that's it. That's writing a formula given a name. But let's suppose that I give you the formula and ask you for the name. Can you go to that and say that's aluminum and that's phosphorus? So it'd be aluminum phosphide since it's binary. That's pretty easy, isn't it? All right, I'm on page 568, example problem 2. What would a chemist name the compound CuCl? Copper is Cu. The hardest part is finding it on the table. So we're going to go over here. Boom, there it is. And copper is Cu. And Cl is chlorine. It's over here. And then we're going to say Cl, O-R-I-N-E. Okay, but it's not copper chlorinide. It's not copper chlorine. It's copper chloride. And if you give me that as the name, pretty close, but it's going to be wrong. And the reason is for table number 2. Look at table number 2 on 566 and on the back of your periodic table, which you printed off from an assignment a couple days ago. I have them listed right here. I call them the dreadful 7 that have more than one oxidation number. On this page 566, there are only 4. Copper, iron, chromium, and lead. If I added 3 others to this list, vanadium, tin, and cobalt. Multiple oxidation numbers. They're metals that are primarily from the transition metals right in here. And they have funny oxidation numbers because you don't need to know. You'll find out in chemistry. All right, so the question is, what kind of copper is this? You owe me a Roman numeral. Well, let's ask ourselves, how many subscript? What's this subscript right here? What's that subscript right there? Well, if it is missing, it's understood to be a 1. So I want you to put 1 circle above each one of those. So what's that 1 circle have to have in it? We don't know, because it could be copper 1 or it could be copper 2, according to table 2. But we do know what chlorine is from the periodic table. We come over here and we go to the top and it's -1. What number goes right there to balance out a -1? Well, it'll be a +1 because it has to add up to 0. And so it's copper Roman numeral 1 chloride. And what if I gave you this formula? Let's see. Oh, okay. I'll do this instead. Forget copper. Well, I'll go ahead and do it. What's that? Well, what is the subscript? There's a 1 and there's a 1. So give me 1 circle up here. This is the way we do it. You don't have to use the circles after you get used to doing it. You don't know what this is, but you do know what that is. Oxygen is -2. It's right up above the oxygen group. It has, 6 electrons in the second energy level. It wants to have 8, so it gets 2 more. When he gets two more, it becomes -2. All right. Anyway, what number balances out -2? +2. So it is copper Roman numeral 2 chloride. Now let's try another one. Let's try this one. Let's call it PB. And let's go PB3N4. How about that one? Well, PB is lead. We found PB on the table, and it's over there by lead. And it's Roman numeral we don't know. And this is nitrogen, so we call it nitride. And nitrogen happens to be -3 on the periodic table. So you're going to go, let's see. This has a 4, so we're going to go 1, 2, 3, 4, and they've all got a -3 in there. This has 3 circles. What number goes in those 3 circles to balance out -12? How about +4? So this is lead Roman numeral 4 nitride. And that's the way you do it. What about this right here? What's the name of that? Is that just magnesium oxide? You do not owe me any Roman numerals because magnesium is not one of the dreadful, it's not one of the dreadful 7. It's not on that table 2 there on page 566. So go over to page 569. 569 has something special, a polyatomic ion. What's the form? What is the definition? It's a positively or negatively charged covalently bonded group of atoms. You see this thing right here, oxygen? Well, let's suppose it looked like this. That would be copper 1 chlorate. ClO3 on the table. ClO3 on the table is -1, and it's chlorate. What? There's a 3 there. I know, but that right there is a covalently bonded group of atoms that act as one ion. They act just like the oxygen does, except the oxygen is -2. This is -1. Because it says so on table number 4. You see it right there, chlorate, -1. And if it's -1, then this has to be +1 because there's only one of them. So it's copper 1. What's the name? Oh, parentheses. What's the name of that? Chlorate. What do most of these polyatomic ions end in? Let's look at the table. Acetate, chlorate, nitrate, carbonate, sulfate, phosphate. If you see the 8 ending, you know it's a polyatomic ion. Okay, so let's use some of those. I want you to write me the formula for lithium phosphate. Lithium phosphate. Well, lithium is Li. And by virtue of ending in ATE, you know that that's not phosphide. That's not P for phosphorus. That's PO. PO what? Look on the table, table 4. Or I've given you the table 4 on the back of your periodic table. It's right there. I got all my little cheaters on the back of this periodic table. You got to pick yourself up one. Print that thing out from online a couple days ago on your assignment. I printed it on there. Okay, polyatomic ion that's P, that's phosphate. Well, on the table it says it's PO4, and it is -3. It says that on the table. This whole package is -3. Well, what's lithium? Well, look on the front of the table. On the front of the table, lithium is in group 1. It's +1 when it ionizes. So +1, -3. So guess what? Crossy says to put a 3 there. You put a 1 out here, you put parentheses around it, but you don't have to, because if it's a 1, you assume it's a 1 by invisibility. All right, so it's Li3PO4. Because you only need 1 of these whole packages. Well, let's try something else. Let's give you a double whammy. Let's make it iron, Roman numeral 3, oxide. No, not oxide. I want it to be carbonate. Iron, Roman numeral 3, carbonate. Well, iron is Fe. Carbonate, ATE ending, polyatomic ion, go to the table, is PO4. Or no, carbonate, CO3. And what is its charge as a package? -2. And what's iron? Roman numeral 3 means it's +3. And so Crossy says to put parentheses around this and put a 3 down there and put a 2 over here. And the formula is Fe2 parentheses CO3 parentheses 3. Of course, these are not part of the formula. These are not part of the formula. They're just a means of getting to the answer. Okay? So if I give you that name, you should be able to give me this formula. And you use parentheses, so you wouldn't want 33 oxygen atoms. You want 3 of everything inside. That's the way we do polyatomic ions. And then I'm going to go a little longer tonight. What if I give you the formula? Instead of the name, you give me the formula. What if I give you the formula and you give me the name? Notice if I gave you that formula, you owe me a Roman numeral. If I give you this formula, you do not owe me a Roman numeral. If I give you that formula, you still owe me a Roman numeral. You got to look at that first item, the first metal, and see if it's in that table. Okay, this time I'm going to give you a formula and you give me the name. Here it is. This is magnesium. This is carbonate. That is not called magnesium carbon triple oxide. It's called magnesium carbonate. Is that pretty easy? What if I went like this? Then you owe me a Roman numeral, because iron is one of the dreadful 7. So you're going to go iron, Roman numeral. Carbonate is -2, isn't it? Off of table 4, -2. And so this has to be +2. There's 1 of these. Wait, there's a 3 there. I know, but there is an invisible one right there. There's really only one of those whole packages. -2. And so what is there over here? There's an invisible one, +2. Got that? So if I give you the formula, you can give me the name. Let me do it again. Let me go with magnesium. And let's go with, there's one up here called hydroxide. I'm going to need 2 of those because hydroxide, so the name of this is magnesium hydroxide. Done. Okay, flip the page. 570 at the top. Naming binary covalent compounds. These are all ionic compounds, metal followed by non-metal. But what if it's non-metal followed by non-metal? Let's name this thing right here. You know what that's called? That's called dihydrogen monoxide. If you have 2 vowels together, you drop one. Well, dihydrogen monoxide, what's the other name for it? Of course, it's water. Let's do another one. Let's go like here. This is carbon dioxide. See the 2? Di. Let's look at those prefixes on page 570. 1 is mono, 2 is di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 is octa. So N2O, and you never use mono on the first element. If you go like this, it's not monocarbon dioxide, it's just carbon dioxide, see? Mono can be used on the second element, but not on the first. See? Dihydrogen monoxide, monoxide. Okay, so what is this one right here? That's dinitrogen monoxide. What is this? That's nitrogen monoxide. What is this? Dinitrogen trioxide. That's naming molecular compounds from formulas. If I give you the formula, can you give me the name? If I give you the name, can you give me the formula? Carbon dioxide, that's CO2. Dihydrogen monoxide, that's H2, mono means 1, oxygen. If I give you the formula, can you give me the name? Dinitrogen monoxide. If I give you the name, can you give me the formula? Yeah, back and forth. And then the compounds with added water, we're not going to do that. So you know why I took you overtime tonight? I took you overtime because this is going to be my last lecture. From now on, for the next 2 weeks, we are going to review. And I have an interesting way of reviewing physical science. We're going to start watching some YouTube videos. And they're going to be under 10 minutes each. If they aren't, I won't pick them. And then at the end of the video, I'm going to ask you 2 questions. And they're going to be really easy if you watch the video. See ya.